All right, absolute value inequalities. Absolute value, if you remember, is a number is on the distance a number is on the number line from zero. So essentially now it's kind of the same definition, but now it's asking for something that's instead of equal to a distance of 4 from zero, it wants all the numbers that are greater than a distance of 4 from zero. So that's kind of an easy one to graph. Here's 0, 1, 2, 3, 4, 1, 2, 3, 4. So this would be all the numbers including 4. So we'd have a closed circle because we want to include 4 in that mess. All the numbers more than 4. So that would be, 5, 6, 7, all those. And, here is negative 4. Well, negative 4 is a distance of 4 from 0. And all these numbers to the left are also a distance of more than 4 or more. So your final answer to this would be x is greater than or equal to 4, or x is less than or equal to negative 4. And you need to kind of get used to the notation for this. So let me hit pause for just a second. I couldn't come up with a name at 10 o'clock at night. So it's interval notation, and you need to get used to that. I'm going to have a video on interval notation that I'm going to require everybody to watch. But interval notation is essentially this. We're dealing with x is greater than or equal to 4. So we would include 4 in that, and it would be all the numbers from 4 to infinity. But we can't include infinity because there's always another number after that. So infinity is really not included because it's not a number. It keeps going on and on forever. And then the same would go here, but in this case we would start at negative infinity and go to negative 4, but we include negative 4, so that's boxed in. Okay, and so that would be our notation, I'm pretty sure. Okay, next thing here. What happens if you go the other way? Let's say it was the absolute value of x is, let's say I did greater than, so let's do less than. Let's do less than 3. So again, we want all the numbers whose distance from 0 is less than 3. Okay, so kind of easy to think about. I'm going to complicate it with all the symbols that go along with mathematics. But so here's 3, here's negative 3. But it would be all these points in between these two. So I'll put a little, 0.5, negative 0.5. Here's 0.5, here's negative 0.5. 1.5, all these numbers, little, 1.25, those all satisfy that equation up there. The numbers that don't satisfy it would be 3, and so we'd have an open circle there, and negative 3, because it has to be less than 3. Well, 3 is not less than 3. 3 is equal to 3. So in that case, 3 and negative 3 don't count. So this one's done a little differently. This is called a union, or excuse me, an intersection. The previous one is called a union, where we have to have the left side or the right side to make it true. In this case, there's two inequalities we have to look at here. The answer to this would be x is less than 3, and this is a conjunction, and x is greater than negative 3. So we need the word and in there, because if you think about that, if we graph those separately, I'll graph this x is less than 3 in blue. Okay, that would be from 3 and then all these points back here. And then if I graphed this x is greater than negative 3 in red, that would be from here and all the points to the right. So, 4, 5, 6, all those. But the and guarantees that it has to work in both. So it has to work in both x is less than 3 and x is greater than negative 3. So that ensures that everything in the middle here, where they overlap, is what we count. You can think of it this way: if I go to the movie or have popcorn versus I go to the movie and have popcorn, well, to make that true, if I go to the movie or have popcorn, if I just have popcorn, that's true. If I just go to the movie, that's true. Whereas if I had to set it with the word and in the middle of it, I go to the movie and I have popcorn. If I didn't have popcorn, I just went to the movie, that would be a false statement. Or if I just got popcorn and didn't go to the movie, also false. You need them both with and that's similar here. Both things have to be true. Okay, and so there's kind of where I'm going to stop with this. I'll do some other more complicated examples and give you kind of a trick on the next video. Here, I can finish with the trick here. Essentially, if you don't want to go into thought, there's a student taught me this way back. Adam, I do believe it was Adam Mosel from Orchard, Nebraska. But anyway, the word, greater than, if you change that to great or than, and then that's telling you, so that last problem when we had x is greater than or equal to 4, the greater, this is telling me that I'm going to have 2 with an or. It's either going to be x is greater than or equal to 4 or x is less than or equal to negative 4, where you flip the inequality and change the sign. And the other word, so greater means or, less than, Adam replaced it with an and, less and. And so it's kind of a mnemonic device to help you remember. And if you've seen that, it was x is less than 3, well, it was and for the conjunction, and x is less than 3, and x is greater than negative 3. And so those are your conjunctions. One thing I did forget to tell you is we don't ever write ands in this way. Ands we combine into one sentence. Negative 3 is less than x is less than positive 3. Put your smallest one first, then your middle one, or then your variable, then your biggest one last. And so that's how we write ands, and so we don't have to write the word and every time. So there you go. Kind of a complicated one, but hopefully it made sense to you. If it doesn't, please comment on my videos. Tell me, ask a question. I would love to answer questions on these. So, best of luck on this, and see you next time.